Alright, we're back to a solar cell, a simple circuit for a whole solar panel. Here I'm showing the ideal current source, the diode model, a shunt resistor, and a series resistor. And we're going to explore the parameter of ISC, or short circuit current, for a solar panel. Important things to know is the diode does not conduct any electricity if the voltage across the diode is less than 0.5 volts, or it's very, very, very small. So small we're going to call it zero. The nominal operating voltage for a solar panel is around 0.6 of a volt. The interesting thing is, if the voltage across the diode is, okay, what did I do there? So small that it's basically the current going through it is zero. The current from the photodiode, the ideal current source, goes up to the node, through the series resistor. It gets shunted or shorted out by a test lead. I don't know what that is. I've got a circle in my drawing. And back to the ideal current source. In essence, the output of one of these solar panels, I out, is equal to the photocurrent minus the current that goes through the diode minus the current that goes through the shunt resistor. Okay? The short circuit current is equal to the output current, and is equal to the photon current. In other words, I short circuit is proportional to the irradiance on a solar panel. You can actually use it as a radiometer, a way to measure the radiation from the sun. I haven't gotten to this part yet, but standard test conditions for a solar panel, STC, assumes 1000 watts. The solar panel temperature, or solar cell temperature, is 25 degrees C, or 77 degrees F, and the atmospheric mass, or thickness, is 1.5. Okay? And they usually give you on the back of the panel a term called I short circuit. And I drew a point here to represent that. 1000 watts per meter squared. And this is the diode characteristic they give you, and then they give you an open circuit voltage. Okay? If there's less light due to clouds or low sun angle, so that the radiation gets lower, this curve shrinks down. This is a current versus voltage curve, and VOC is open circuit voltage. In my previous video, I said that's approximately 0.6 of a volt times the number of cells in the solar panel. Now, what's really misleading about all this is the standard operating temperature is assumed to be 25 degrees C. On the back panel, they'll also give you a nominal operating temperature, and that's what is expected to happen when you run this solar panel in the open circuit voltage mode. Okay? Sorry for the cough. So, I haven't touched any math yet, and I'm trying to get the point across in this video that ISC, the short circuit current, is directly proportional to the light. Now, if you live in a desert where there's very few clouds and the humidity is very, very low above the land, you can actually get more than 1,000 watts per meter squared. If you live near a coastline where you have clouds, you can get a whole lot less, and you can get to the point where you get no power out of your solar panel at all. Okay? And what surprises people is that in the wintertime, the open circuit voltage gets larger. Okay, and that's important for selecting charge controllers. And in the summertime, the open circuit voltage actually gets smaller and reduces your output power in the summer. And that's enough for this video.